Welcome back, cowboys and cowgirls. It's been a few weeks, and I'm excited to tell you what I've been doing with my indie tower defense game, Recolonizer. In the first episode, I built a little skeleton of an idea, which looked and felt decent, but something was missing. Where's the fun? So to recap, after a day or two of coding and putting together pieces of old prototypes, demos, and assets, I found myself with a complete gameplay loop, solid foundations in terms of code, but also some major UX issues, and a general feeling of pointlessness to how it played. So let's take a look at what we have in place today and evaluate what needs to be worked on. So, gameplay loop. We have a build cannon, kill ship, get money. Okay, no notes. Moving on to UI. Let me try to illustrate with an example. A whole bunch of ships are sailing towards you menacingly, and I, the developer, pose you a question. Which cannon do you want to build? You wonder, which one? So many options. But I only see a small, non-illustrative picture of the cannon. I don't even know what they do. I respond smugly. Just compare stats, dummy. Start by picking a cannon to view its stats. Picking a cannon, but which one should I pick? You ask. Just anyone, the first one, whatever. Great, man, look, you can see the stats. Now go back and compare the stats with other cannons. Click cancel and... What? Ships are coming. Click build. No, you have to strategize. Compare pros and cons, not just panic. So it's obvious I have to streamline the cannon build UI flow for version 2. I gotta reduce the screen back and forth, I gotta keep everything visible, reduce the number of clicks to build the cannon, generally makes stats easier to compare. I still want to keep the fixed position of the cannons for gameplay reasons, and I like having the buttons there, so no drag and drops for now, you know, like I don't want to change the foundations there, but you know, the first solution was to build a larger panel with the same icon buttons as the previous design, but with the stats always shown on the top parts. You can click on the cannons to show their stats still, but the button always, you know, is there. We reduced it to 2 clicks. So yeah, I guess it works a little better. It's not the best solution, but you know, one thing at a time. Okay, UI annoyances out of the way. Let's take a look at what makes Recolonizer Recolonizer. Where's the fun? I wanted to mix up a bit, but not too much the, you know, general gist of what tower defense is about. Every game must be aware of the feelings that it's trying to instill on the player. In Recolonizer, the player is intended to feel pressure from the ships approaching, satisfaction from seeing a well-upgraded cannon absolutely wreck some enemies, and pride from coming up with a strategy that works well. What makes Recolonizer fun is the uncertainty of it all, not knowing where the ships are coming or going. You can't see their paths, but you can learn them, strategize, and win. So what's missing in V1? Well, a lot. We don't have much satisfaction because we don't have upgrades and we don't have a cool way to show them or the damage that they deal. We don't have much pride either. We don't offer many choices of weapons. It's not much pressure, also it's too quiet. You know, we should add a ship horn sound effect to signal their arrival and make waves get harder and harder. Right now it's just the same enemy over and over in a loop. It's not too exciting. But to make the player really uncertain and to add even more pressure is to add multiple map locations to defend at the same time. This will really put the player in a multitask mode, forcing them to really think about how they spend their time and focus. So what's the plan of attack for V2? Well, the to-do list is fucking huge. Am I already losing track of the scope? It's gonna take me forever to do it, let alone talk about it. You can see by the release date of this video. Let's at least keep this video in scope. and talk about some changes to the game world and how the camera works. In version 2, the camera is no longer fixed to a position, like a security camera. Some of the testers, all the testers, as soon as they got their hands on the phone with the game installed, they tried to put 2 fingers on the screen and twist or zoom or drag to see more. I felt so wrong depriving everyone's natural instinct to see more of the game world in a game that you have to, you were kind of like enticed to see where the ships are coming from. So I felt like I had to do something about that. So how does the camera move? I wanted to implement it myself, so I drafted up this idea. Picture the screen, which is 2-dimensional, and the game world, which is 3-dimensional, where the camera exists in. When you move up and down on the screen with your finger or mouse or however, the camera moves forward and backwards in the world. And when you move left and right on the screen, the same happens with the camera, relative to its own position. To zoom, I figured we'd do the same as a real camera does and just reduce the FOV value. Nice and simple. So, excited to get to work. I knew I was using the input system already, the new one. And so I figured I'd just listen to a mouse move event and move the camera by getting the pointer delta value. Let's get to work. Okay, let's see what it does and... what? No, we have a few issues. First off, while it worked kinda well in the editor, granted I had to tweak the sensitivity value a bit. As soon as I built it for web, iOS, Mac, and Windows, and I realized that each platform felt quite different. Like they had different sensitivity values. And when the camera was angled, the speed at which it moved also felt off. Looking back, this was a big learning moment for me, so I want to discuss this one in more detail, as it was a case of web dev brain attempting to do things in Unity. So to recap, this is how things are done in web development. Web development is event-based, so you have a mouse move event, and you subscribe to that event, and when that event happens, by some magic of the browser, you run the update position function, or whatever you're reacting to. Same with click, react to the click event, you do something. It's simpler interactions for the most part, and the web is a place where loading times of the pages are more important than responsiveness to input. There's an expected small delay anyways when you're clicking between web pages, so it's a different environment. You say like priorities are different, right? In Unity, it's a game, so a game runs every frame, right? It's constantly like giving you this callback and calling different events in the life cycle. I mean, like if you web develop, like similar to React, old React classes in some way, but those happen at specific render events, not every frame, right? Like here we're talking about frame by frame based. It's event based, but it's on an interval, right? Event in the sense that Unity calls these events, right? But they're like functions that you define and they're called by Unity's magic, right? But it's at the end of the day synchronous code most of the time. The game's always ticking, multiple frames per second, high expectation of responsiveness, high frame rate, and so on. But within Unity's input system, we have the possibility to do both. It's a designer's choice in the end. But in the learning stage, that's not really the impression I got at all. This game dev Stack Exchange thread is a good example. There is some nuanced discussion, but all the responses tend to lean towards just do events, it's superior, it's better, it's gonna save you complexity, blah blah blah. On YouTube, it's not that different either. The videos tend to be tutorials focused on getting you up to speed with the new input system features, which includes the event-based workflow. But instead of framing it as, you can do both, here's how to do either, and here's reasons you should pick one over the other, blah blah blah, they typically frame it as, this is the new thing which will replace the old. This long tirade is just me avoiding responsibility for my own choices, in particular the choice of event-based as opposed to polling. Let's stop for a second and reflect as to why. Well, cameras move on a frame-by-frame basis, depending on the changing position of the mouse between the frames. Things that move frame by frame typically need to have a predictable rate of change. Do we have this predictability with input polling? Well, in Unity, yes. Polling inputs on update is quite predictable, as we can adapt the movement speed by using, time delta time, which tells us the time in between frame renders. What about this event-based? Do we have an event delta time between the changing position events? Well, it turns out it seems there is no clear documentation on this, and the best discussion on the topic was in this forum post, which, to be honest, I only found when I was writing the script for this video. I had to find out by myself that the rate of event emission is indeed device specific. So the end result was terrible camera movement. Even though I kinda got the effect I wanted, the implementation had unacceptable side effects. Why am I in this field anyways? Just to suffer? Apparently yes, because that is not the only issue with my initial design. The second issue is determining from my scene setup what exactly can the camera see. And this is important, just to have a clear idea of what's off screen and what's on screen, right? We have things spawning, ships spawning off screen, and we don't want the player to see that. This makes the developer experience terrible when designing new maps, or very time consuming. There's too many variables. The center of the camera view changes depending on position, rotation. I don't even want to think about what I have to do to address this. Without fixing the issue at the root, I'd have to have some patchwork calculation to be able to give me an answer. So what's the root of the issue? Well, it's controlling the camera like a stupid human instead of the camera target, aka where the camera is looking at, and then just having another script to make the camera follow this target with some constraints. Hint, that Cinema Machine does that for free. So it's time for a rewrite, I guess. Second time's the charm, right? This time I try to do some research beforehand and implement a tried and tested solution instead of rolling my brand new cowboy custom in-house solution. Well, it'll still be in-house, just adapted to my needs, but not created in a vacuum. And guess what? One Wheel Studio put up a great article on how to do an RTS cam exactly with the features I was looking for. And some additional ones that I, in case I change my mind and want to expand even more the camera movement. Go check out this video on the topic. And rewrite I did. Thankfully it wasn't as hard as I imagined. In my version of the code I had two input actions, enable camera panning and camera pan direction mapped to mouse click and mouse delta respectively. And we had callbacks for those when they were performed. So the camera pan direction, it basically is what should be actually running in the update loop. It takes the mouse direction and then tries to make it move. And yeah, we try to keep it in bounds also. And the way that changed was actually quite significant. So, how are things done differently in the advanced camera controller? Well, as I said, everything's done on updates, right? Like instead of callbacks. So on update, we drag the camera. It also has the keyboard movement if we want to move using WASD, but since this game is gonna be mobile first, I wanted to do the drag, make sure the drag's working well. And the drag works a little bit differently because now we take the pointer position and then project a vector, right, like a ray out of the screen using that pointer position onto a plane that we just, invent on the origin coordinate, and we checked the movement of that plane across frames and use that to build a directional vector to our target position. And that target position is just a vector that we keep a reference to. We accumulate that, right, like on update, and on late update we then update the velocity and the position of the camera using that vector, right? And that works quite well. We had to figure out some of the mobile stuff, and we can get into it, but all in all, it's quite simple, right? Like this is basic Unity stuff, but I had my head set into using the new input system. And I just forgot, you know, how to do basic shit. But yeah, that's learning, and it kind of works like really well actually. I think we must get out of the way first that the zoom is no longer done via FOV, right? It's done by setting the height of the camera. And let's get the second thing out of the way, which is the irony of the fact that zoom is still done via an input system callback. But it's still, we can do that because we're still doing the right thing in Unity terms, right? We're still updating the camera position on late update every frame. Right? It's just what are we using to as an input to be the target position that the camera is going to be moving towards, right? And this is what happens in zoom. So in zoom we set the height, and on update we move towards that target height that we set. And the movement is technically, I guess we could put that also on a callback. So here it is. Our new camera system implemented using input polling against the internet's advice and with event callbacks with the internet's advice. And controlling the camera target like a pro, you know, and using Cinemachine to keep the camera aiming where it's supposed to be. And now the bounds also correctly represent what the camera can see. At its most zoom in spot, we still have to, you know, test the higher zoom spots if we're not showing anything we don't want to. But it's much easier to design levels now. And now that we have our camera working, let's make sure that we have one of our core mechanics implemented. Adding multiple locations to defend at the same time. To up the pressure levels, we shall overwhelm the player with an insane number of possible threats. The idea is we have these locations that you can defend, and the enemy may or may not sail close to those locations on their way to your base. The cameras can move within the bounds of those locations, which may be in the same island or it could be different islands. And may or may not share also building spots if they're in view. To help you situate yourself and see the big picture, I'll add a map camera that shows all the locations at once. Now I need to write a location manager to handle the list of locations and control which camera is active. And location UI to display the list of locations on the bottom of the screen.
Oh my god!
Or project them on the map itself when we're like in the bird's eye view. So now that we have multiple locations, we have multiple splines that the ships can follow. So I'm gonna add that on the spawning script. You need to select which spline you want the ship to be spawned on. And I, as the level designer, need to make sure that we have waves going to the different locations and so on. I'll do random generation later. And now for some final touches, I'll add some names and icons to make them sort of recognizable. And voila! Location manager is up and running. Now take the original level and add location to the left. This will be the tutorial. And this location is not a target of attack, just a pass through, teaching you the mechanic to filter out enemies before they get close to your inner defenses. And let's see the completed level after all the modifications. And it looks pretty nice. Now I just need to add some ships, cannons, and upgrades, and we'll have a full, complete, solid tower defense game. Be sure to catch that on the next devlog. You can play open beta on your browser for free today, and for free on iOS very soon, and for $5 on Steam also very soon. Thank you, and see you next time.